Okay, is audio is clear by now? Even please.
Audio is not correct 100%.
Even PPT is also not visible from my end.
Visible or not visible?
Visible to me, but audio is not that clear.
Slide is visible, but audio is not clear.
Okay. So let's continue for a while, and after 5 minutes, I will again ask if the problem persists. Then we will see what to do with it.
Now it is okay, ma'am.
So these are the generic questions that can be answered by the GIS. Okay, thank you. So if there is a lot of problem, then you can inform me. I will stop the lecture for that a while being. Then I will start the class again. So now what I am getting that my audio is coming okay to you. There might be a little bit disturbance, but more or less it is clear. Okay. So therefore I'm going to continue the lecture, and if there is any problem, you can immediately inform me. Here we were discussing about the generic questions that can be answered by GIS, and the summary of the same is listed over here. The generic question that a GIS can help to answer can be summarized as: where are particular features found? What geographical patterns exist? Where have changes occurred over a period of time? Where do certain conditions apply? What will be the implications if an organization takes certain action? Now we will see how the GIS can be defined by different people. So previously it was the generic questions that can be answered by the help of GIS. Now there is a list of definitions that are given by considering different type of people. First one is for the general public. If you go to the general public and ask what is GIS, the general answer is simple. It is a container of maps in a digital form. This is what the GIS is for them. So it is a container of maps in a digital form for the general public. Now, if we move to the next, decision makers, community groups, planners, what is GIS for them? GIS is a computerized tool for solving geographic problems. Okay. So if there is any type of geographic problem over there, then we can use the GIS to solve that thing. In the previous lecture, I have told you that GIS acts as a spatial decision support system. Today, I can find some of the students who have joined the lecture for the first time. So all these students must download the recording of the previous lecture. Okay. So I have started the GIS from the previous 10, although we have started our classes back in August and the students were reading the book chapters, making some tutorials and other things. Those students who have joined this week only, they also need to do the tutorial that was given earlier, but I will give you the sufficient amount of time. There will be no hurry. So you can take 1 week or 2 weeks to complete that tutorial. Okay. So next is, if we see the definition of GIS for the management people, for the operation research, it is a decision support system that can help to solve some problem. Next one is for the utility managers, transportation officials, resource manager. What is GIS for them? Okay, what is utility managers? Like suppose a manager in the electricity company. Okay. So why do they need GIS? Suppose there is some electricity company. In that power distribution company, what will be the use of GIS or how GIS can be used over there? They are saying it For them, it is a mechanized inventory of geographically distributed features and facilities. So, if we talk in reference to the electricity company, you can find that there are several things like there will be poles, there will be transformers, there will be electric power lines, transmission lines, and all these things. They need to place a proper record of all these things. There must be an inventory. You must have heard this term inventory, especially in database, we use this term inventory. Okay? It is like listing all the items that you have. There will be an inventory, what things you have, whether you are in library, whether you are in house, wherever you are going, you need to maintain an inventory that keep the record of all the things that you have or that organization have. Here also, when we have geographic information system, then in that case, it will help us to prepare an inventory so that all the things, all the schools, all the whatever you are working on, like electricity company, they are working on pole, transformer, transmission line, they must keep a proper record of all these things. GIS will help them in such type of inventory creation, inventory maintenance. Next thing is scientists and investigators. What is GIS for them? Okay. For them, GIS is a tool for revealing what is otherwise invisible in the geographic information. Like, um, suppose I will give you the land surface temperature. Okay. We have satellites like the Landsat satellite whose data is freely available. It collects the data in the thermal band. You will learn all these things in the remote sensing part. But the Landsat also collect the data in the thermal range so that the land surface temperature can be obtained. Now, if you simply see the land surface temperature, okay, that is a temperature, that's it. But if you want to say that there is some urban heat island at that particular place, how you can say that thing? That there is some sort of urban heat island at that particular place. So here again, GIS can be used to tell you what is otherwise invisible. Okay, I will show you one such example. Wait a minute. Okay, there is again some internet issue, I think so. Just wait for a minute. I have hope so this screen is visible to you. Right now I have opened.
Ma'am, nothing on the screen.
Okay.
No, I'm not.
Ma'am, now visible.
Now you can see that I'm showing you the land surface temperature map, and this map is of Kolkata. Okay. So now, with the help of GIS, some of the analysis has been done, remote sensing and GIS, image processing. And here you can find some pattern. Okay. The temperatures are mentioned over here, very high temperature, high, moderate, low, very low.
Ma'am, not visible.
No, it's visible.
I mean,
Mm,
visual.
Visible. It
Other
is visible,
students,
ma'am.
please confirm. Is it visible?
Ma'am, nothing is
Yes,
visible.
ma'am.
It's coming black.
Yes, ma'am. It's black.
Visible.
It is visible, ma'am.
Ma'am, at my side it is there.
I'm just waiting for a minute. It is visible, but it may take some time for some other students. There might be internet issue at your end.
Visible, ma'am.
Is it visible now?
Yes, ma'am.
Yes, ma'am.
No, ma'am.
Just wait.
Okay, no problem. If it is not visible to some of the student, no problem. You already have the PPT, isn't it? I have already uploaded the PPT of GIS technology, the GIS 1 introduction. Okay, open that PDF if the screen is not visible to you, because the screen is visible. At my end, it is visible. I have connected with both laptop and mobile, both, and it is visible on my mobile. And other students are also saying that it is visible to their end. So if any of you is not able to see the screen right now, just open the GIS technology PPT. Okay. So open slide number 17 of that one. Today there is some internet issue, I think so. That's why this sort of problem is occurring. Those students who are not able to see the screen, open the slide number 17 of the PDF, GIS 1 introduction. Yes. Now I am moving back to the thing that I was telling you, that how GIS is used to reveal what is otherwise invisible, like the temperature. This one is the land surface temperature. I'm considering a particular one. So in this one, you can see the legends are marked at the bottom: very high temperature, moderate temperature, low temperature, and very low temperature. Now with the help of GIS, all these things have been marked on the screen, and you can see that there is a river-like structure. This one is the Ganga River that is going through Kolkata. And here you can see the temperature is very low, because the temperature of water is usually low. And the nearby area you can see red color or maroon color, because it is the city area, built up area, and the temperature is very high. If you move away where D and C is written, okay, you can see this place D and C. As you move away from that place, you can find again the temperature is falling, because the city is surrounded by the vegetated area and also by the wetland. So if there is a wetland, if there is a marshy land, again the temperature will automatically get down. So this pattern is also visible on the screen with the help of GIS. So this is how the GIS can be used to show you what is otherwise invisible. Next one is for resource managers and planners, how we can define the GIS. So for them, GIS is a tool for performing operations on geographic data that are too tedious or expensive or inaccurate if performed by hand. What does this mean? This means that suppose you want to collect the geographic data. Okay, if you want to collect any the data that has latitude, longitude, the spatial information. Nowadays, with the help of GIS, with the help of GIS software, we can easily collect all these data. In the next laboratory session or the coming Monday, we will learn about the digitization. Okay. So again, you will know how to collect that data. If that same data is collected manually, in that case, it will get too tedious. It will become too expensive because you have to employ a lot of people at that time. That's why the GIS is a tool that helps people to maintain the data in an inexpensive way. So these are the different definition of GIS that is given by the different people. This one is a general definition, but if we go to the literature and try to find some of the standard definition, few of them are given in the next slide, which are the GIS definition. So these are the different definition which are listed over here. Among these definition, the second definition is very popular. It is given by Burrow. In your copy, write down this name, P.A. Burrow. Peter A. Burrow. Burrough. Peter A. Burrow is again a very popular name, is in the field of GIS, and he has given some of the initial books in GIS. So what is the definition of GIS by Burrow? GIS is a set of tools for collecting, storing, retrieving at will, transforming and displaying spatial data from the real world for a particular set of purposes. Okay. So this is what GIS is. In each and every definition, there is something is lacking, some more things need to be added. That's why the rest of the definitions are modified. If you see the third definition, it is very much similar to the first one, but it is adding something new. Like the first definition doesn't involve checking. It means once you collected the data, you need to verify that data. You need to ensure the accuracy of that data. So if you go to the third definition, which is given by the Department of Environment US, it says GIS is a system for capturing, storing. The third word is checking. Okay. So they are saying that we need to capture, we need to store the data. It's okay. But we also need to check that data, integrating. What is the meaning of integration? In GIS, you will hear this term repeatedly, integrated geographic database. Integrated means that you are collecting the data for different for the different sources. Like suppose I will create a database for a road, I will create a database for school, I will create a database for um, say for higher education institutes, and then we are going to combine all these data, all the spatial data, all the attribute data of road, of the schools, of the higher education institutes. So this is what we are doing. We are basically integrating the data and creating an integrated geographic database which is containing all the information. That's why this new term integration is added. Manipulating. Again, manipulating is something that is not bad in GIS. Even when we say manipulation, that person is doing manipulation, it means that person is doing something wrong. Okay, we do not use manipulation in a positive sense. But in GIS, we use the term manipulation. It means that we are going to change data, we are going to perform certain operation, and we will manipulate the original data into something else. So there is nothing wrong doing in manipulation. It is a general term, positive term in GIS. Then analyzing that data and displaying that data, which are reference to the Earth. The fourth definition of GIS includes the component of GIS. It says GIS is a system of hardware, software, people, and organization for collecting, storing, retrieving, transforming, analyzing, and disseminating information about the area of Earth. The next two definitions are very narrow definitions that are taking a particular view that GIS is a decision support system that helps that involving the integration of specially referenced data in a problem solving environment. The last one says GIS can be viewed as a DBMS, database management system, to support spatial as well as non-spatial queries from the user. So this is how we can define the GIS. There are different definition of GIS given by the different researchers. There are some narrow definitions. Some definitions are very broad that covers all the functions, all the components of GIS. But the whole purpose of this definition, where I have discussed the definition of GIS given by the researchers, some general definition of GIS for different people. The purpose of all this thing is that all of you must be able to define what GIS is. Okay, in your own term, you need to define what GIS is. So your task is, I'm giving you 2 minute time and you need to write down the definition of GIS in your own word. Try to write down the definition of GIS in your own words, how you will describe GIS if somebody asks you. So all of you must have told that, I have taken the admission in MNIT. Okay. So next question with that will be asked by your friend or by your relative is, आपकी branch क्या है? कहाँ पर लिया है मैंने NIT में? You will say, I have taken admission in Geo-Informatics. Then they will ask, what is Geo-Informatics? I haven't heard this term before. So you will say it is something related to GIS and remote sensing. What is GIS? What is remote sensing? They will ask. Then you need to define what GIS is. Okay? So just think about it, how you will describe GIS to some of your friends, to some of your relative who do not know anything about GIS. Based upon all these definition, आप कैसे किसी को समझाओगे कि GIS क्या होता है? Okay? वो आपको बोलेंगे कि अच्छा ये कुछ सैटेलाइट से जुड़ा है, अच्छा आप इसरो में जा करके काम करोगे? नहीं, आपको बताना पड़ेगा कि GIS क्या होता है. ठीक है, सो 2 मिनट का टाइम लीजिए, इसको अपने टर्म्स में अपने नोटबुक में लिखिए कि आप अपने शब्दों में GIS को कैसे डिस्क्राइब करोगे किसी को. I think so all of you have tried and written it. The definition of GIS. Okay. So in the page where you have written the definition of GIS, leave that page. And over the time, as you learn more and more about the GIS, try to refine the definition which is just written by you. Okay. Based on a very short lecture of 1.5 days, you must be able to write something. Okay, maybe right, maybe wrong, but you have written down something. So over the time, try to refine that definition. That's why I'm suggesting you to leave that page. Okay. Now we are moving to the next topic after the definition of GIS towards the evolution of GIS. How the GIS has been evolved. Okay. In general, we used to say that GIS is evolved from 1960s. Okay, when the very first computer-based GIS has been developed. Who was the developer of that GIS? Canadian Geographic Information System, CGIS was the name of that GIS. Who was the developer of that one?
Roger Tomlinson.
Yes. Roger Tomlinson is considered as the father of GIS, and he has created and he has given the very first computer based geographic information system for Canada. So this is how we mark the starting of GIS. But before that, before to this computer based full fledged GIS, there is one very popular example in the history. Okay. This was given by Dr. John Snow. Okay. So all of you, you have 2 minutes time again. Search about Dr. John Snow. Dr. John Snow, London City, cholera. These are the few keywords that you need to write down over there. Dr. John Snow, London, cholera. Here you can find that how the GIS, how the not GIS, but how the geographic information system has been used in the past also. Okay. Search about it. So I think so. You people have gone through this particular topic, Dr. Johnson, cholera, London, and other things. So I was telling you to read about him. Anyone?
Ma'am, he mapped the cholera-related deaths and he plotted the point of cholera death on a map and with water pump location. This approach helped him to see the concentration of death and also determine which water pump was responsible for spreading the disease.
Yes. In London, or particularly around the London, there is a Soho. At that place, at some time, I have to check the year. Yes, in the year 1966. Okay. In the year 1966, what he has done, he has created a map of some unknown disease. At that time, people do not know about any disease, and just people know that there is some problem, there is some unknown disease, there is some disease that is spreading in the London city, and anyhow, people are getting dead because of that. Okay. So as it is written over there, that people used to think that cholera was spreading because of some sort of air related pollution. So what Dr. John Snow has done, since people do not know what is the reason of the death, what is the reason of the disease, they do not know anything about that one. What Dr. John Snow has done, he has taken the record of all the people who has died because of this unknown disease. Okay. And then he has taken the map of London. As you can see on the screen on the right hand side, there is a map, and on the bottom side, okay, this particular map is the original map, which is which is created by Dr. John Snow. Okay, on this map of London, he has marked all the people who got affected, who got died by this particular disease. After mapping, what he has found, that there is a cluster of victims, and he do not know what was the reason of that disease, but at the center of that cluster he found that there is one water pump. Okay, so he said that I do not know anything about the source of this disease and why the disease is spreading at this location. But based upon this map, I can say that since there is a water pump located at the center of this cluster, somehow this disease is related to the water of this pump. Later on, the water pump was, people stop using that water pump, and the administration has removed its handle. Later on, it was found that this disease was nothing but the cholera, and the disease cholera is a waterborne disease. And how Dr. John Snow has found about that disease? By plotting the data of victims. Based upon that data, based upon the cluster analysis, he has identified about the water pump, although he do not have any information about that thing. So this is how he has used the geographic pattern of disease to find out the solution. Okay. So this is how one of the very first example of GIS was given. Go through this article. It is interesting one. You can find several research article on this particular topic about the John Snow, about the water pump, and how he has plotted all the cases and identified the things. So you can read about this, but we are coming back to our main topic about the evolution of GIS. So this particular example was given to you to tell that, GIS is nothing new. The use of geographic information is not new. From long time back, people are using the geographic information to solve the problem. The people are using the location based data and other things to solve the problem. Nowadays, we have GIS and there are several technologies, GPS and other things, so that the location based problem can very easily be solved. But in the past, our ancestors were also using this geographic information to solve the problem. One such popular example in the history is of Dr. John Snow. Later on, after the lecture, read that article in detail. Okay. Now we are coming back to the present GIS, where we consider GIS, Geographic Information System, as a computer-based system to solve the problems that are related to location. The whole evolution of GIS can be divided into three eras: formative years, year of maturing of technology, age of information infrastructure. Write down all these 3 years in your copy. 3 points that are mentioned over here. Write down the heading evolution of GIS and note down all these 3 years. Formative years, its time period from 1960s to 70s. Decades of information infrastructure from mid 1990s to the present. Okay. Now we will see one by one how the evolution have taken place.
In the last line, I was not able to write completely.
Okay. Audio, my audio is okay or not?
Yes, no, it is okay.
There is a little bit of lag on the screen. That's why it will take time to change the slide.
Done, ma'am.
It's now coming.
Ma'am, it's done.
Okay. the the formative years is coming from the year 1960s up to 1970s. Okay. As it was mm, covered earlier, that the very first GIS was developed in the Canada. Okay. Write down this Canadian Geographic Information System in your copy. Canadian Geographic Information System, conceptualized in early 1960s and operational in 1971. Conceptualized in early 1960s and become operational in 1971. Okay, so this CGIS, how the requirement of CGIS was identified in Canada, the government want to collect the information of its land resources, because for the taxation purpose, if you are putting some tax on the people, you must have a proper information about the land, you must have the proper information of the land use. You must have the proper ownership information of land. Okay. So basically what they want to do, they want to make an inventory, CLI, Canadian Land Inventory. So we have earlier, when we were discussing about the different definitions of GIS given for the different type of people, we have discussed the term inventory over there. Here also, there is a department, Canadian Land Inventory, and they want to prepare a proper inventory, proper detail of land in Canada. Hired a person called Roger Tomlinson. Again, write down this name, Roger Tomlinson. Okay. So, who is Roger Tomlinson? Roger Tomlinson is the person who has headed, who is the leading the team which has developed the Canadian Geographic Information System. Inside the bracket, write down father of GIS. Okay. So Roger Tomlinson is considered as the father of GIS. At that time, this task, you can just try to imagine what is the task. Instead of taking the whole Canada, take your home district. Okay, whichever district you belong, whether you are Prayagraj, Jaunpur, Pratapgarh, Kanpur, wherever you belong to. Okay, just try to think if somebody asks you to create a complete land information of your area. Could you imagine this task? For example, if I take the Allahabad only, Prayagraj, the area is around 5,500 square kilometer. There are 8 tehsil, 21 block, and thousands of villages inside the Prayagraj. And now, suppose if I do not have any sort of computer, like it was in 1960s, at that time, there was no laptop, there was no such type of scanner. At that time, they have to perform the surveying of the whole Canada by using the limited resources, very limited resources, because yes, computers were there at that time, no doubt about it. But you can think about its efficiency. Like you can think about the computers that was 15 years back. Okay. So in your early school time, you may have used the computers at that time, how the computer was, what was the size of computer, what was the processing power at that time. You may not realize these things because you were not using the computer like that way for the processing and other purposes. But yes, in 1960s, the resources are very limited. The technology was in a nascent phase. Okay. So that's why this task is a very big task, because he has developed the CGIS for the whole Canada by using all the resources, whatever was available at that time. That's why, because of his exceptional contribution in the field of GIS, Geographic Information System, he has been termed in many places as the father of GIS, because at that time there was no such thing GIS. There was no such methodologies through which you can perform the analysis and other things. Everything was defined. That's why this is the formative years for the GIS. Everything was defined at that time. Okay. Next, it is about the different advances in the field of remote sensing also. What is the role of remote sensing in GIS? Can anybody think and tell me about this? What is the role? Remote sensing GIS के लिए क्या करता है?
It fetches the input data without being in contact with the directly which about which geo information is being needed.
Okay. Anyone else?
Ma'am, GIS helps to visualize or interpret remote sensing data. We use GIS technique.
Okay. Anyone else?
And remote sensing helps you collect the data, and GIS helps you use data and
Collecting organizing and refining and data analysis.
Okay. So basically, yes, so everyone was correct, more or less correct. So remote sensing basically serves data to the GIS. Okay. So if you are performing any sort of analysis in GIS, when we take the images, all that thing is handled by the remote sensing. Okay. Now, if you are making any map, if you are performing any survey, then it is not a remote sensing. But nowadays, you will find that a lot of remote sensing is used in GIS. A lot of remote sensing. In the practical session, in the present semester, and in the next semester also, you will find that how the remote sensing is has become an very important part of GIS. You cannot work on the GIS without having the remote sensing data most of the time. Okay. So that's why you will see the all these development are interrelated. You know, GIS is not independent. GIS is related to remote sensing. GIS is related to computer science. So all the development that is taking that is taking place in the field of remote sensing, in the field of computers, in algorithms and other things, everything is interrelated, and GIS is getting affected by all these things. I think so. My screen is not now visible, is not visible now. Is it visible?
No, ma'am.
No,
No,
ma'am.
ma'am. No, ma'am.
Okay, okay, wait a minute. So it is not visible now. So I'm going to continue. Meanwhile, it will get visible to you. Okay. So the remote sensing is very useful. And in 1972, there is a launch of Landsat satellite. Okay. Now, what is the importance of Landsat? Why we always say Landsat when we talk about remote sensing? Because Landsat data is freely available. Anybody can use the Landsat data. Later on, you will learn how to download the data from USGS website, Earth Explorer website, and you will find that wherever you are living, you can download your data. You just need the internet, and you can download the Landsat data very much easily. So this has also helped in the development of GIS. All these are the formative years. So if we see the table, in 1957,
Ma'am,
there is a, yes,
slide is not visible.
yeah, slide is anyhow not visible. Please open your PDF. I will tell when it will get visible. Open the slide number 24.
Ma'am, where is it located in 5 section? Because there is.
I'm talking about these slides, GIS1 introduction.
Ma'am, there is no slide, ma'am. Ma'am, there is only a book and one chapter.
No, no, go to the class material.
Ma'am, there is only three documents: GIS introduction, GIS book, and principle.
Yes, ma'am, there is no PPT.
Open GIS introduction. It is a PDF file.
Yes, ma'am.
But
PDF of
ma'am,
pages.
that is not this slide one.
Okay. Just wait a minute. I'm trying to share my screen, but yes, now it is visible. You can see on the screen. So there's some confusion regarding the
Yes.
regarding the yes. So this is how this file section is coming: class material and recording, isn't it?
Yes, ma'am.
Inside the class material, there is this GIS introduction, one GIS introduction.
Yes, ma'am. But in this, your slide is not that. That is not the slide, ma'am.
Okay. Wait
Ma'am,
a
it is a
minute.
book.
Yeah, wait a minute. I will just remove it. Now it will appear GIS1 introduction. Okay. Now you can download that slide, but right now the screen is visible, so I'm going to continue this way only. So this is about the era of innovation, and you can find the several type of innovation that have taken place in this era. The very first one is 1957. Okay. So type is application, first known automated mapping produced, Swedish meteorologist and British biologist. Automated mapping means GIS is used a lot for the mapping purpose, simply for the I want to map all the schools of Prayagraj. Okay, so this is how we are using the GIS for the mapping purpose. The very first example of the same was given in 1957. The next one is in 1963. Okay. So as we have discussed earlier, CGIS development was initiated in this year, in the year 1963. So Canada Geographic Information System is developed by Roger Tomlinson and colleagues for Canada Land Inventory, CLI. This project pioneers much technology and introduces the term GIS. So that's why this CGIS is very important for us. Then in the year 1963, there are different, like the Urban Resource Information System Association founded in the US soon become point of interchanges for GIS innovators. Okay. Next, 1964, Harvard Laboratory for Computer Graphics and Spatial Analysis is established in the direction of Howard Fisher at Harvard University. In 1966, SciMap, the first raster GIS, is created by the Harvard researchers. These are all the year of innovation, and the very first application, the very first association, the very first conference, the very first laboratory, all these things have been established in this particular era. So you can think that GIS is quite a new thing, and its innovation has been started from 1957. Okay, there is not even 100 years for this technology. Then DIME, yes, there is a name. US Bureau of Census develops DIME, and DIME is a data structure that is used for census purpose for storing the data. Just wait for a minute. Yes. So these all are the different development. Then there are different companies. As you can see over here, there are several commercial innovation in this time also. Like in 1969, ISRI, Environmental System Research Institute has been established. Write down this particular innovation. All of you write it down. 1969. ISRI was established. And what is the full form of ISRI? Write down inside the bracket. Environmental System Research Institute, ESRI. Okay. Does anybody know the software which is produced by, which is developed by ISRI? It is quite popular in GIS.
ArcGIS, ma'am.
Yes.
Yeah. The ArcGIS, which is a proprietary software, licensed software, and that software is developed by the ISRI. So that's why you need to write down about this ISRI, Environmental System Research Institute, ESRI, and then write down the name of the developer as it is written in the notes section, Jack Dagermont and Laura Dagermont. Write down the name, Jack Dagermont, Jack, Jack Dagermont, and Laura, Laura. Jack and Laura Dagermont has established this particular firm, ISRI, where in California. So Jack Dagermont, a student from the Harvard lab, and his wife Laura from ISRI, form ISRI to undertake projects in GIS. Next development, again, it is a popular development. Write down in your copy, 1969, Intergraph Corporation formed. Intergraph Corp was formed, 1969. Any software of this particular company, Intergraph? All of you check the internet and search the name of the software, GIS software, image processing software, given by the Intergraph Corp. Yes.
Redas Mary?
Yes. Initially, it was of Intergraph, nowadays it is of hexagon geospatial. So Intergraph, the ADAS imagine software that we use for the image processing purpose. Initially, it was launched by the Intergraph Corp. So ADAS is a very popular name. Again, it is a proprietary software. It was given by the Intergraph. Now, next one is 1969. In this particular year, there is a book called Design with Nature was published. Later on, it will come in our discussion. But here it is just written that in the year 1969, Design with Nature, this book was published. Why this book is specifically mentioned in this section? Because the author of this book was Ian McHugh. And in this book, he has given the concept of overlay analysis. Okay. What is overlay? Okay. Just suppose, um, okay. Um, suppose you want to draw something. Okay. You have one design on one paper and or instead of giving this example, like suppose there is some area, okay, and the road network of that area is drawn on one map, on one sheet of paper, okay, and the bus stop of the same area is drawn on another sheet of paper. Now if you want all this information on a single sheet, राइट नाउ इट इज गिवन ऑन अ टू सेपरेट शीट. एक शीट पर आपके पास में रोड मैप बना हुआ है, रोड का पूरा नेटवर्क बना हुआ है. एक शीट पर, पेपर शीट पर आपका सारे के सारे जो बस स्टॉप है वो बने हुए हैं. अभी आपको ये दोनों डेटा अलग अलग नहीं चाहिए, बल्कि एक साथ चाहिए. एक एरिया का पूरा रोड और सारे के सारे बस स्टॉप एक साथ में चाहिए. अब आप इसके लिए क्या करेंगे?
ओवरलैप कर देंगे मैम.
नॉट ओवरलैप, ओवरले. ठीक है, दोनों जो हम लोग इन जनरल ओवरलैप करना कहते हैं, ओवरलैप मतलब एक के ऊपर एक रखना. उसी तरीके से जीआईएस में यहाँ पर जो सही टर्म यूज होता है वो है ओवरले. ठीक है, तो जब आपके पास में दो अलग अलग डेटा है, उस केस में हम ओवरले कराते हैं. ये कॉन्सेप्ट किसने पहली बार दिया था? इट वाज गिवन बाय इयान मैकहाग इन हिज बुक कॉल्ड डिजाइन विद नेचर. That's why this book is very popular. When we discuss about the overlay analysis, we used to say that this concept of overlay analysis was given in the book Design with Nature, written by Ian McHugh. Okay? And later on, you will find so many application, a lot of use of overlay analysis, because majority of time you will have separate layers for all the data. And whenever you need to answer anything that require both the data, two or more set of data, in all those cases you have to perform overlay analysis. Okay.
मैम जो
Yes.
हम AutoCAD पे काम करते हैं मैम, लेयर वाइज पे, तो हम ये भी तो एक ओवरले जैसा होगा.
Repeat करिए क्वेश्चन.
मैम जो हम AutoCAD पे काम करते हैं तो उस पे सारे लेयर्स पे होते हैं, हर डिफरेंट जितने भी रिक्वायरमेंट होते हैं, हम लेयर इंट्रोड्यूस करके फिर सबको मर्ज कर देते हैं. मैम वो भी तो एक ओवरले का ही कह सकते हैं कि हाँ ऐसा कुछ होगा.
ऑटोकैड मैंने यूज नहीं किया, लेकिन जिस तरीके से आप बता रहे हैं मुझे जो समझ में आ रहा है कि सपोज अलग अलग लेयर्स हैं और आपने कोई मर्ज ऑपरेशन करा करके या यूनियन ऑपरेशन करा करके उन सबको एक साथ ले आए हैं. प्रोबेबली आप ये करने की कोशिश करते होंगे उसमें. तो यस, ये ओवरले एनालिसिस में होता है कि हम लोग अलग अलग लेयर्स को एक साथ ज्वाइन कर देते हैं, मतलब यूनियन कर देते हैं. जैसे मैथमेटिक्स में आप लोग ने पढ़ा होगा सेट का यूनियन होता है, उसी तरीके से यहाँ पर लेयर का भी यूनियन कर दिया जाता है. तो वो भी ओवरले एनालिसिस में ही आता है.
थैंक यू मैम.
Okay. Then in 1969, first technical GIS textbook was given. 1972, इसको जरूर से लिख लीजिए और एकदम याद रखिए. In the year 1972, Landsat 1 was launched. Write down in a copy. It is very useful, whether it is GIS, whether it is remote sensing, whether it is satellite image processing. Everywhere you will find this particular satellite Landsat. So right now we are working on the Landsat 8 data at present, but the very first Landsat, the Landsat 1 was launched in the year 1972, originally named as ERTS, Earth Resource Technology Satellite. This was the first of many major Earth remote sensing satellite to be launched. Okay.
मैम
Then
ये
in the
वही
year
होती है जो जीपीएस की
1973,
L1 L2 L5 इस टाइप की मैम?
sorry,
हाँ मैम, जैसे
repeat
जीपीएस
करें.
ग्लोनास की L1 L2 L5 इस टाइप के?
नहीं, जीपीएस तो अलग चीज हो जाता है. ये लैंडसैट जो है ये आपको सैटेलाइट इमेजरी देते हैं. ओके. आप
ओके.
आप अगर जीपीएस डेटा की बात कर रहे हैं तो जीपीएस में अलग पर्पस के लिए यूज हो रहा है वहां पर. ठीक है. यहाँ पर पर्पस रिमोट सेंसिंग है. वहां को पोजिशनिंग करने के लिए जो स्पेस में जो सैटेलाइट्स भेजी जाते हैं, एंड वो 24 सैटेलाइट का कॉन्स्टलेशन है जिसमें कि कुछ सैटेलाइट्स को 4 और मोर सैटेलाइट्स को यूज करके पोजीशन निकाली जाती है. वो अलग पर्पस है. यहाँ पर अलग पर्पस यूज हो रहा है. यहाँ लैंडसेट का जो काम है वो अलग अलग बैंड्स में अर्थ को इमेजिंग करने का काम होता है इनका. ओके. नेक्स्ट इज in the year 1973, first digitizing production line set up by Ordnance Survey, Britain's national mapping agency. Again, the Ordnance Survey, which is the Britain's national mapping agency, it also has a lot of contribution in the field of GIS. 1974, Autocato 1 conference held in Virginia. There is a conference. 1976 again. Okay, so rest of the academic developments were there, but these all are the major events that have taken place in the era of innovation that involves the establishment of CGIS, then the development of various commercial organizations like ISRI, Intergraph, the concept of overlay, the launch of Landsat 1. All these things have been taken place in the era of innovation. Okay. Second one is the era of commercialization. In this particular era, all these companies have given several softwares. Okay. First one is the Arc Info. Again, write down this name. At present, we use Arc GIS. Okay. But previous to Arc GIS, there is Arc Info, Arc Arc View. Such type of things were used previously. So write down this particular thing. In the year 1981, Arc Info was launched. So the company ISRI, okay, in 1969, the company ISRI was established, but its product came in the year 1981, and the name of that product was Arc Info. Arc Info is considered as the first major commercial GIS software. And you will find the use of ArcGIS a lot in most of the companies that are working in the field of GIS. They are using the ArcGIS software. Okay, so ArcGIS is not ISRI is not just only launching different softwares, but they are also doing a lot of training session. They are also doing conferences and other things. Okay. Then, yes, in the year 1985, GPS became operational, which is again a major milestone in the development of GIS. Nowadays, with the help of GPS receivers, we are able to collect the location of any place. Okay, it is easy to collect the data. It is easy to click geotagged images nowadays because we have GPS receivers, because we have inbuilt GPS in our smartphones also. In the year 1985, this GPS become operational. So the general term is GNSS, Global Navigation Satellite System. The GNSS of United States of America is called GPS. There are similarly of Europe, Russia, China. They are known as GLONASS, Galileo, Baidu. So these are the different names, but most of the time you will find GPS and GNSS as synonyms. Okay, but they are not synonyms. GPS is a type of global navigation satellite system. With the help of GPS, you can get the information of location. Yes, in the year 1986, the book that I was earlier discussing, Principles of Geographic Information System for Land Resource Assessment, was published. Peter Burrows' book was the first specifically on GIS principles. Okay. So in the definition section, I was telling you about the Peter Burrows' definition of GIS. His book, write down this name. You know, you need to write down all these things, because if you just read all these table, you will forget everything. You will not be able to remember anything, but some of the important points are there that need to be written down, that need to be remembered by you. So when we say some of the important milestones in the field of GIS, you must be able to recall all these milestones of GIS. So write down the name of this book, Principles of Geographic Information System for Land Resource Assessment. All these things are looking quite theoretical right now, but after few lecture sessions, things will get more practical and you will start using all these data and other things. Since it is the introduction section, therefore it is quite theoretical in nature, but you need to remember all these things. Okay. During interview session, many times students are not able to answer the name of GIS books. They have done the MTech and other things, but still they are not able to answer what is the name of any GIS book, what is the name of any 2, 3 GIS journals and other. So you must have this theoretical information. The question usually asked by the people in the interview and other places. है ना? तो ये थ्योरी है और ये बोरिंग है, ये सोच करके इसको छोड़िए नहीं, इसको याद रखिए, ये आपसे पूछे जाते हैं. We must have written the name of the book, Principles of Geographic Information Systems for Land Resource Management by Peter Burrow. So why this book is very popular? Because it is considered as a very first book which is specifically based on GIS. Then map info, another firm that gives the GIS software, was established in the year 1986. Then in the year 1988, you can see after 2, 3 entries, Tiger was announced. What is Tiger? When we say Tiger in GIS, it is not Salman Khan, it is topologically integrated geographic encoding and referencing. Okay, write down this full form, Tiger. Topologically, you can find it out over here. Topologically integrated geographic encoding and referencing. So this is what is Tiger. Oh, Tiger is again, it is a data type that is used by the United States Census Bureau. Some of the initial development were done in the Census Bureau. Why? Because if you see the census data, I have told you that the census data doesn't just mean the collecting the number of men, number of women, number of children, total number of people. This is not just the data which is collected by the Census Bureau of any country. there are a lot of socio-demographic data that is collected by the Census Bureau, whether it is of United States, whether it is of United Kingdom, whether it is of India. You will find all the administrative boundary. They have their own village boundary map also. So since they need to collect all this data, that's why you will find several initial development in the field of GIS involves the Census Bureau of United Kingdom, of United States. So Tiger is a file format, a very popular file format that is used to store the road related data. Okay. Then there are some other developments. You can read about them. Then in the year 1994, executive order was signed by the United States President Bill Clinton. Okay. Write down the name, this detail. So what is done by the President Bill Clinton in the year 1994? He has signed an executive order whose number is 12906. Okay. Write down the name. Executive Order 12906 signed by US President Bill Clinton in the year 1994. Now, why it is mentioned over here? Because by the help of this executive order, they have given the United US National Spatial Data Infrastructure Clearinghouse and FGDC, Federal Geographic Data Committee. Okay. Now, what is the meaning of all this thing? You know, when we talk about the infrastructure, okay, leave this thing, executive order and US, UK, other things. Just think in a general way. Suppose if I say infrastructure, what will you consider in infrastructure? What will be in infrastructure? You will consider road as an infrastructure, electricity as the infrastructure, water as the infrastructure. So what we used to say, roti kapda makan. So these are the basic requirement of the people. And when we say about the basic infrastructure, it will involve the electricity, water, road, and other things. But with the help of this executive order 12906, the information was also considered as the infrastructure. Whatever information is there, like how many schools are there, how many seats in the school are there, such type of information is considered as the infrastructure for the citizen of that country. From this point onwards, there is a concept of spatial data infrastructure, which was given by the United States, but later on it gets spreaded and become popular in so many countries. Even in India also, we have NSDI, National Spatial Data Infrastructure, Indian NSDI. There are some other terms which are associated with it, clearinghouse and FGDC. We will learn about all these things in the next semester when we will learn WebGIS subject. Okay, so right now, this particular point was highlighted because it has suggested that just like the other things, information must also be considered as the infrastructure, and the citizen must have a right.
Ma'am, voice is not coming.
Time the web was introduced, it was invented. So as you know, there is an internet. Am I audible now?
Yes, ma'am.
Anyone else? Please confirm my audio is coming or not.
Yes, ma'am, it's coming.
Audio is okay, isn't it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So I was telling you about the internet and web. So on the internet, there are several services, okay, like FTP, like Gopher, like Telnet. Among all those services, one of the services is called web, World Wide Web. It has become so much popular that people used to think that internet and World Wide Web are synonymous to each other, but it is not. World Wide Web is one of the service that run over the internet. And since it is free of cost, since it is open, it is platform independent, it can be used on any platform, whether it is Windows, whether it is Linux, whether it is Macintosh, it doesn't matter. That's why it get very popular. But when we have such type of services, we need certain rules and regulations so that the things will take in a proper manner, in the orchestrated manner. That's why there is a W3C, World Wide Web Consortium, that gives the rules and regulations so that the things will work smoothly. The client will know how to make a request, the server know how to answer that request. Similarly, in GIS also, there was a requirement of some consortium, some body that will give us some rules, regulation, protocols so that the things will work smoothly over the web for the GIS purposes specifically. Therefore, in the year 1994, Open GIS Consortium, nowadays we say OGC, Open Geospatial Consortium. Okay. In the year 1995, OpenGIS or OGC Consortium was born. So the OGC Consortium of OpenGIS Consortium of GIS vendors, government agencies and users is formed to improve the interoperability over the web. Okay. Then over the time, several GIS related products were launched like Autodesk, of companies like Autodesk, ISRI, Intergraph, MapInfo, and they have started to produce a whole set of products that are internet based. So this is all about the era of sorry, era of commercialization. Later on, the last era, which is the era of information infrastructure, which is also known as the era of exploitation. In all this era, there is more and more development of the previous things. Okay, all the things that have been taken place in the previous, in the era of formation, in the era of commercialization also, more advanced things get produced and more things getting on the web. Initially the things were on desktop. Okay, like I have some GIS, I have some product that can be accessed only on my system. But in the era of exploitation and with the development of web GIS, the things are getting over the internet. That's why in this era you will find most of the development are internet based. Okay? If we talk about the remote sensing, the resolution become very fine. A very high resolution data get produced. One of the popular name in this field is Iconos. Iconos is the name of a satellite that gives 90 centimeter ground resolution. Another satellite is QuickBird, which was launched in the year 2001, and they claim the resolution of 62 meter on the ground. So very high resolution images uh, were obtained in this era. Then several softwares or web GIS based software were launched in this era, and many of the organizations that were producing the products in the field of GIS, they started giving online services. Okay, so all of them are listed over here. The SDI, the clearinghouse, all these things that were done in the previous era, now were actually implemented in this era, and people have started to get more and more data set easily on their own system. Okay? So this is how the GIS have been evolved over the time, and the concept of LBS, location based services, was also given in this whole era. Okay? So that's it for the evolution of GIS. We have discussed about it. All of you read these slides, which is describing about the definition of GIS, about the evolution of GIS and other things. Okay. So that's it from my side for today. If any one of you have any question, you can ask. No question? Okay. So, okay then. So I have
Ma'am,